Okay, so in this video, I want to show you guys in the course a little bit about this cloud platform I was talking about. It's now connected to the course, and so it will allow you to log in via Brightspace and take a look at all of the exam. So we have lots of code in, sometimes we have code in the homework assignments to illustrate stuff. Sometimes there are special notebooks for the lectures where we illustrate stuff in Python notebooks, and so this cloud platform is a way that you guys can directly just click from Brightspace and take a look at those notebooks running on the cloud and run the code and change the code and play around with it if you want to. It will also be the place where we will ask you to submit where you guys can work on in Teams, actually, not Microsoft Teams, in actual real Teams. You use Teams, Microsoft Teams for chatting if you want, I don't care. Where you will work in Teams on the final project. So I'm going to show a little bit about the platform, how to get into it, and as we move towards final project, I'll tell you a bit more how to work together in Teams and that, but we'll post a separate video about that. So first, how to get there. So it's pretty easy. Let me actually go here, view as students. So in principle, this is also what you will see. So if you go to, I've made it, you get into the platform. It's called Vocareum. You can see the tab here already. You get into the platform via Brightspace. You have to first log into the Brightspace page, and you go to content. And we're already here. There's a link here, Vocareum, and set content area. Vocareum has a link too that will bring you to Vocareum. And if it's the first time you click, then it will also create a new account in our Vocareum course based on your net ID information, on your student information. So actually, that's an important thing if you want to start working together as a team. You have to have students in the course yet. That's why I cannot yet demo how to join a team and how to work together in a team. Okay, so unfortunately, if I click on this, I go to the instructor side, but I've got a little hack for that, so I won't click, but if you click, then you should be brought to it should create a new tab in your browser, which will bring you to here. So this shows you the Vocareum overview of the course. Over here are the different assignments I've created. So two of those assignments are not actually assignments you hand in, they're just places where I can share notebooks with you. This is an actual assignment. So you can see these have no due date, for example, but the final project does have a due date, but I can't show you that because there's no students in the course yet. So okay. Yeah, okay, I'll show that later. Okay, but first let's go to the demo notebooks. So the first thing I've done actually is I've taken all the notebooks that we've created in the course, which have some sort of Python code in them, and I've uploaded them to this platform, and in the demo notebooks assignment here. So, and the idea is that these are notebooks you can go in and click on them and run them and play around a bit with the code if you want, and to see in live action what is various stuff related to the course. Now, the one thing is that I might come up with more this year for fun, and so, but one limitation of this platform is if I want to update this with adding new notebooks, the only way for you to get them is to reset and download all the stuff. So if you've made any changes to those notebooks, then you'll lose them, unfortunately. So the idea, that's the idea of the second assignment here, a space to play around. That's basically just an empty assignment where if you want to play around with code, if you want to play around with code in general, you can just go there and create Jupyter notebooks and play around them and with them, and run code, run stuff and see what happens. You can also say copy, if you want to really take one of the assignment, one of the demo codes that we provide and actually play with it and tweak it and modify it or something. I would actually recommend that you do that by copying and pasting into a notebook here where you can play around, so that if we later put new notebooks out in the demo notebooks, that you can reset your assignment without collaborating the stuff you've done. So that, without further ado, let's see how it looks. So the way it works is you click on this button, My Work, and that will create on some server in the cloud a running Jupyter Notebook server, which is already preloaded with all of these notebooks that we wanted to share with you. So, and the way it works is you can click on a notebook. I've actually uploaded a whole bunch of notebooks. If you click on a notebook like this, it will load, and then you can see it, and then you can just run cells. So I've got a whole bunch of code here. Actually, this is the fun one. This is what I was sort of discussing in class, how to experimentally check whether or not your noise is uncorrelated. Just slice it into two bins and average those guys together and see, and you get a new data trace of fewer points, and see if the scaling of that noise follows what you expect, which is 1 over n. So I actually do this with artificial, just noise from NumPy. So we're testing NumPy. And there's a sort of interactive plot widget that I've made in the Jupyter Notebook. And this shows you the standard deviation, I think. I have to check the code. I should label my axes. Shows you the standard deviation of the trace. And then this slider allows you to change the number as a function of the number of points you average together, up to like 1,000 or so, or 600, 500. And then this slider allows you to change. So over here, it shows you the time trace. Actually, it's to average and a non-average one, but a number average is 1, so that's fine. And then I can grab the slider and I can pull it, and then I can see what the trace looks like if I say average together, 13 points. And of course, if I average together 13 points to make a new data trace with fewer points, first of all, I have fewer points, but also the noise goes down, and you can see that directly here. Cool things that, so I do this using Buka, actually. Many of you may be familiar with Matplotlib, but Buka is much faster for these types of interactive plots. So actually I changed this, I just modified it the other night to work with Buka, because it's much more snappy interface. Actually what would be kind of cool is actually to make a third plot that shows you the histogram, the two histograms, and you can see the histogram shrinking. Okay, but maybe someday. So, and then maybe another example here is what I was talking about in lecture, with the fact that the Fourier transform of a noisy trace is not really, it's sort of nearly the power spectral density, but it's not really, because you have to do this ensemble averaging to get the smooth curve that converges to the theoretical power spectral density for a large number of ensemble averages. These were these brackets that look like an expectation value of quantum mechanics, but in this case, in classical limit, it's just ensemble averaging. So this is basically some code that I've hacked together to do that. You can, if you're a Python enthusiast, you can go in and take a look at how I've done all this. But this is what you see. So the orange curve shows, well, not quite theoretical, because I didn't bother to calculate it and get the normalization right, but let's say the maximum number of averages, which looks pretty close and it's pretty smooth. But you can see if I just take one trace and don't do any ensemble averaging, I get this super noisy thing, whereas the theoretical power spectral density should be the smooth peak. And I can grab the slider down here using IPy widgets, and I can see how as I turn up the number of averages, that actually the curve gets smoother and smoother and eventually converges to, well, of course it converges to the orange streaks. That's just the one with the maximum number of averages. But imagine that there was a smooth theoretical curve here, then it would converge to that. Okay, actually there's some fun stuff with, I mean, if you've ever done this with Matplotlib, I mean, Buka is amazingly smooth and interactive. But actually Buka, for those of you, I'm becoming a Buka enthusiast myself. You can, if you click here, you can actually slide the axis up and down. You see by default it was auto scaling the axis, but if I do that once, then you can see that now the axis doesn't scale, and you can see more clearly what happens as I start to add to start to add more and more averaging of my ensembles to estimate my power spectral density. Yeah, and Booker, you can do something, zoom in, zoom out, and just grab it around and drag it. And you can zoom in on axis if you want. If you have over the axis, zoom in on y-axis. I'm a bit of an enthusiast. Good. So that is an example of the whole idea is to make it super easy for you guys. You don't have to install anything, you just click and you can already start running the code. Now, the one thing is that Vocareum is mostly based on having one notebook per assignment, but then I put like 10 in here. So how do you get back? One way is to put, well, I discovered tonight you can just push the back button. But actually you might say want to have a bunch of these open, and you can always do that by opening them in new tabs. That actually works. You lose this little title bar at the top, but that's okay. And you get this really funny URL, but yeah, that's all right. And now you can see, now you can actually then, this is my life, I live in tabs. I just flip back and forth between tabs and flip back and forth to my virtual desktops, lots of tabs, browsers, lots and lots of tabs. But yeah, it's a good way for me, I find it a nice way to work where I can have lots of notebooks open and have a look at them and run the code. Good. So maybe let's go back. I guess I just back again. Yeah, that works. So if I go back to the main page, I can also go to this other one over here. And then I might, if I go open this, of course, like I said, it's just empty. And I want to show, let's say that I want to play around with some code. I can make a new Python notebook based on Python 3.8, I guess. I don't know. And then here, if I want, I can just go to my other notebook and say copy paste some code. Kind of like this, C, and then V, and then I can run that same code over here. And I can start playing with it. And so if you really want to play around with code or recode something or add stuff for fun, I don't know if you have time to have fun, then I would recommend you do this in this sort of playground area. Because if there's more notebooks that release into the demos, you'll have to reset the assignment, and then you'll lose all the changes you made. I'm not sure there was a particularly easy solution to this problem, actually. Oh, I pushed the wrong button here. Let's go back. So maybe I'll show that quickly. Let me go back to where I was. I guess if I put back enough times, there we go. So if, for example, we come up with some cool new code that we want to release to you guys, what we will do is we'll put it in the demo notebooks assignment part, and then you can download it, the new code, and unfortunately overwrite any changes you've made to the existing code. But you can do that by hitting this button right here, reset assignment. And that will then get you the latest version of all the notebooks. Good. I think that, well, so that is more or less it. Aside from this button here, this is a submit button. When you're working on your project, you can actually push this button to register what's currently in your workspace as a submission. And we allow you to do this as many times as you want. Actually, it's not a bad idea. It's like a backup of your of your thing, of what you've been working on. Well, not really a backup, but like at least a snapshot, so that if you forget to push the submit button or something, and then you're like, oh my God, it's past the deadline and I never pushed submit ever, then at least you have something submitted. I also will say that I've enabled auto submit, so that basically when the deadline passes for the final project, again, you only have to submit for your final project, but when the deadline passes for the final project, then all of the workspaces of all the groups will automatically be submitted. And so in principle, you don't need to push submit even. because we'll do it for you, basically. If Yeah, we're gonna really pressure you guys not to go over deadline. We're trying to start super early so that nobody's in a panic last minute to get this done. But if you do go over deadline and you have some particularly convincing reason why you had to make modifications after the deadline, then you can always send us a personal message in the forum and explain why you think that you guys as a group might deserve an exception to the deadline. Good. All right. I think that's all there is pretty much to show about the platform for now. I will warn you already, when we get to lectures 7, for example, that's when we start using Qtip, this super cool quantum software, quantum simulation package. Unfortunately, Qtip is currently not installed on Vocareum. I'm discussing with the support of the company. They promised to do it pretty quickly. So hopefully it'll be installed this week. But right now, if you go and run this code, you're going to get this error: no Qtip, no module Qtip found. So hopefully they'll come back to me soon. And as soon as that is ready to go, I'll let you guys all know. All right, I think that's it. If there's any questions, please, you know what to do. You post them in the forum. So I hope to see you. Well, I'll see you guys tomorrow in any case, and I hope to hear from you guys in the forum.